Hello everybody, and I want to discuss today the value at risk based portfolio optimization, which is in my opinion a very useful tool which in the future I suppose will be a sort of benchmark for the portfolio optimization analysis. Why is it important, this new approach in financial analysis? As you probably know, the Basel Committee in 1998 decided to strengthen the analysis of the risk in banks and financial institutions. So it becomes really important to deal with this system of analysis. The risk is becoming more and more important in the daily activity of banks and financial institutions. Well, let me briefly tell you about the assumptions of the model. Supposed to have a portfolio with n assets indexed by I. Suppose furthermore to have an expected return of portfolio equal to the sum of weights theta j times the expected return of the single asset j and the variance. Furthermore, I introduce a typical feasibility constraint according to which the sum of weights should be equal to 1. Now I start to show the minimization problem a la Markowitz. Markowitz showed that the minimization problem is the minimization of the variance of portfolio, sigma p squared, subject to the expected return of portfolio and the feasibility constraint. So what we have to calculate is the optimal vector theta, which represents the optimal weights of portfolio. If I write the Lagrangian function, I obtain basically this. So I write the set of first order conditions, and I have n plus 2 first order conditions to write, n plus 2 derivatives, and derivatives with respect to the optimal weights, and 2 derivatives of the Lagrangian multipliers. Perhaps is much more useful to use a simple matrix notation. I can write the system in the following fashion: capital psi times capital omega equal to b, where capital psi is the variances and covariances plus expected returns matrix. Capital omega is the optimal vector encompassing optimal weight and 2 Lagrangian multipliers, and capital B is this vector with expected return of portfolio. If I solve the system, I obtain the optimal capital omega star, which is my solution, which is obtained by inverting the capital psi matrix and multiplying it by B. Secondly, I introduce the value at risk based portfolio optimization. It is important to define the value at risk for a given quantile Q. The VAR of a quantile Q is equal to minus the initial portfolio value V0 times this expression, which encompasses this expected return of portfolio minus this parameter c, which varies according to the distribution of our random variable, times the standard deviation of the delta prices. And using a variation of the basic Markowitz portfolio analysis by Sharp, I obtain this expression, which is the return of asset I is equal to alpha I, which is a constant component, plus beta I times RI, which is the portfolio return. This is the deterministic component, plus a stochastic component, which is given by epsilon I. Furthermore, I also write another constraint, which is equal to the sum of betas times thetas, which must be equal to a given capital G. Again, as before, I write the Lagrangian function, which in this case have 3 Lagrangian multipliers. And I also write, for sake of simplicity, this expression with the standard deviation, the derivative of the standard deviation with respect to a weight I, and the derivative of the standard deviation with respect to G, which is this sort of cumbersome expression. Again, I write the set of first order conditions. In this case, I will have n plus 3 instead of 2 number of derivatives. The n optimal weights and the 3 Lagrangian multipliers. So if I exploit a given substitution, I can rewrite the first order conditions in the following fashion. Now, the problem is how to solve this system of equations. Since it is impossible to solve algebraically, this system can be solved according to a very interesting technique I discovered, which is called the Picard's iteration. Actually, I'm not really an expert in nonlinear programming, and because in this case we have to solve nonlinear equations, so I found the Picard's iterations very useful. And this is a sort of iterative procedure according to which we must converge towards a solution. And as you can see, you have some loops and which start the iteration procedure. You run across corner portfolio construction, portfolio standard deviation calculation, and of course we get to a point where the convergence is acceptable. And if it is acceptable, the software which you use to solve this iteration procedure stops and finds the optimal. So just to give you a very brief recap, I showed that there are some differences between the classic Markowitz portfolio optimization and the value at risk based portfolio optimization. Of course, the second one is much more complex because the complexity is due to the fact that it is almost impossible to find solution, and you have to run across this procedure, which is of course requires some programming skills. So if you are interested in, I suggest you to check on Google and to find some useful materials to work on. So that's it. If you have any questions, I will be glad to answer, and of course you can write my email address. Thank you and bye bye.